Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Muhammad Ramizu bin Daud from Space KL. Today I want to share my video presentation for my project Sarjana Muda 2. I choose the topic is to studies on accuracy of AG meter. This is because I want to find the error of AG meters because it will impact for NRW calculation. Okay, before I go detail, so let's me give basic knowledge for NRW. NRW is non-revenue water, where is the system input volume total produced by treatment plant minus bill authorized consumption minus total consumer use the water. That's mean the balance of the input production minus consumption. That's the balance is NRW. NRW also can call as a water loss. Okay. Water loss. So many type of water loss. There are real losses, apparent losses, and whatever. So, meter inaccuracy are one of part of water losses. In a water balance composition is called as a commercial losses, not real losses. Okay. Meter inaccuracy or meter error, this will impact for another level and other calculation. That's mean the water used by consumer but did not record it, did not record uh, exactly. This is a water balance composition. In AW, this is the main of what we call okay, this is a water balance composition. In AW, this is a basic of knowledge. Must know every involved in AW must know the composition of the water balance. So the topic that I choose is this customer meter inaccuracy and data handling error. So it's category in water losses. Okay, this is an AW in Malaysia. This figure is produced by Suruhanjaya Perkhidmatan Air Negara, where the non-NRW for 2016 and 2017. Average NRW for Malaysia is 35.2 for 2016, and for 2017 the figure is increased around 0.4%, 35.3%. Okay, for um, the lowest NRW in Malaysia is champion is for Melaka, and the highest is Perlis. That's mean around Perlis around 63.1%. Water 63.1%. Water produced by production by treatment plant loss. That's mean it's more than 50%. Water produced by consumer just use. That's mean the water utilities just can collect the income around 40% only at the police. So it can give the loss of profit and income for the water utilities and at police. So objective of my study is to find the percentage of error. This error can be determined by comparing data between old meter and new meter, and then to identify the cost to total cost to replace the old meter and return of investment for the meter replacement. Actually, this is to know how much spend money to do the meter replacement, and then for the aspect technical, we use the correct data to predict the water usage for the demand of the water supply for next year and year. My scope of study is I used domestic user at Pulau Langkawi because this area is not complicated the pipeline, and uh, user consumer, not much consumer, at least around 27,000 only compared to other state. I choose the meter aging over 7 years because the factory uh, give a warranty for their meter is 7 years only. That's mean if um, over 7 years the meters is not accurate. So and then lastly we choose a meter size 15 mm below 50 mm. That means it's just only for domestic users. Okay, the method of statement, they have two type of to get the data of the meter error. First, by lab meter testing. So lab meter testing, the test meter we do at the lab. Of course, the data is more accuracy because it's come specific component to test the meter. But the uh, what we call but is difficult to do because we need to carry out the meter to remove meter from consumer meter and then carry to the lab for the testing. So when we remove the meter, consumer cannot use the water because um, they not the connection of the pipe is removed. So one more thing, when we do to carry out to get remove meter from house for consumer to lab, that is more time needed to study to get the data. Second method is meter comparison. Actually, this method is used for to check the large meter because we can remove the large meter over for each to move to carry to the lab to test the meter. Actually, the lab testing for at lab only for 15 mm for small meter. Actually, for large meter, if we want to check meters is still still okay or not, we need to carry to the factory that's make the meter. Okay, meter checking by comparing data with meter test. Okay, this meter checking we use comparing data with meter test. We install for the meter For the last meter, we call a clamp meter. We install uh, before or after the meter, and then we compare the data captured by test meter and sample meter. Okay, one more thing, the comparison is more simple testing when we can do on site and data recorded when consumer use the water. So that's mean we just put 2 meters, and when consumer when consumer use the water is go through where these 2 meters, and they capture the uh, by by meters. This is my statement and the method. First, discussion with the top management to get the permission, and after get the permission, I discuss with technical team to discuss how can we get the data. So after that, we do the testing meter on site, and lastly, when I get the data, I do analyze to finding the result of the studies. Okay, first, the top management, actually I want to for more quick result of data. I just want to flushing the water go through the meter, but it's not the top management uh, but the top management did not allow it, because we call when we just okay. This is what photo during how to get we install the meter testing and meter reference. Uh, we use blue meter as a meter reference. This is a new meter we can bought from factory. We come with certificate that's small error 0.05%. So that's mean is meter is accuracy. So each meter uh, we we connect for connect the meter as a series to connect the meter in a series, uh, because in pipeline engineering state that whatever flow in the same pipe and the same size of pipe, same material, it can give a same flow, same velocity, and the same flow rate. That's why I choose this method to more easily to get the data. Okay, so after I get the data uh, from uh, from Taliwork as a partner. I class for the 3 group, 50 years above for group 1, group 2, 11 to 40 years, and group 3, 7 to 10 years. Okay. uh, for the group 1, 15 years above, around 3,800 total, and around 13% of domestic user use over 50 years meters. Group 2 around 17%, and group 3 around 18%, and others around 50%. Others is include meter below 6 years, uh, last user, and include uh, others. This is the chart for the total of consumer in Langkawi. Okay, this is a finding and discussion for the group 1, 15 years above. Okay, according to this data, uh, for the tens, we just sample for the 10 meters. When we analyze the difference, the error is around 10%. For the group 2, 11 to 40%, the error is around 6%. And for the group 3, 7 to 10 years, the error is around 3%. This is for the group 3 is the total numbers is quite not enough because my country is a PKP, so we need to stop the installation early. So this what I say from the data. Group 1 average 10%, group 2 average 6%, and group 3 average 3%. Okay, from the because from the data we get billing data, the group 1 3,809 user account use around 121,000 meter cube per month. Group 2 2,400 and per month. Group 3 100,000 per month, and others 1.08 million per month. So total usage is around 1.8 million per month. Okay, this is a group water consumption estimation. Okay, this is what I estimate with data error that I get before, where this for group 1 the numbers error is around 10%. So if we replace all these meters, we assume that the average increase around 10%, around 12,000, and totally if we replace this meter, the numbers the total consumption will increase around 10%. And also for group 2, the total number is increased around 6%, and group 3 is around 3%. So the total increase when we replace of this meter is around 38,000, actually around 2 or 3% for the total billing for that month. So for the second objective is to find the costing and return of investment. So if we want to replace for group 1, the total cost spent is around 266,000 ringgit Malaysia to replace 3,809 ringgit. This is basically the cost for meter replacement, around 70 ringgit per unit. So when we replace all this, the total consumption will increase around 12,000. So the increasing water usage, we can get the extra income around 12,000. That's mean around 1 ringgit per meter cube. So when we spend around 260, so the ROI for the group 1 is around 22 months to get the return of investment. For the group 2 is around 23 months, almost 2 years, and group 3 is around 37 months to get return of investment. So the company will choose the best, so the best solution, the best part to replace. Okay, for the technical spec, we need the accurate data from the meter to projection of demand of water supply demand for the next year. Okay, from the data for 2016, 2017, 2018, and 2019, the average of consumption, the monthly consumption is increased around 0.52%. So the demand every year will be increased around 0.52% based on currently usage. Based on currently usage. So that's mean if we replace all these numbers of meter, the actually the average consumption is higher than this figure. Okay, this is what I mean. That's okay. This is a production demand for 016 to 2030. Choose this for the increasing 0.5% every year. Actually, this is red line is this is maximum treatment plant maximum capacity, where it is designed for produce the water. But currently, the treatment plant is produce over the capacity is around 2.91 million per month. Actually, the design of capacity for the treatment plant is around 2.6 million million MLD, million liter per day. Ni 2.6 no 2.6 million per month. Okay, if this is orange line, this is a projection of demand for 2018. So actually when we use the data, currently data is actually the water supply should be okay with the demand and water supply. But if we do analysis with 3%, but what I mean is 3% is increasing if we replace the old meters, so the demand will be increased around 3%. So based on 3% and plus 5% every year, so little bit the demand of increase. So lebih more, what we call more the demand higher than the current situation. So if we project with the 10%. 10% if overall overall error. This is 10% is include what meter error, meter aging, and start meters. Uh, that's around 10% the figure. So the demand will be increased around 2013 30. The average demand is around 2 million. So this is quite similar with design capacity. So uh, to make sure there is no water crisis in Langkawi, so we need do something to cover if demand of supply um, must be okay. If you do have need do planning for increase the capacity, maybe the water crisis will be more quickly. So this is NRW to finding and discussion. But I say that the NRW is 10, declared as 10.17%. This is a water losses for the current situation. The last for 2000, I think is 2019. So the figure is figure out when we figure out this percent. The total 10.2%, 3% is a domestic user. What we get from the data from my experiment data, and 7% is from the commercial users, and meter above 15 meters more to commercial, bulk meters, and meter 40 meters. Okay, the another your losses from fibers or whatever is around 26%, and the, okay, so that's why the utilities did not take action to replace the domestic meters, because the impact for replace of domestic meters is just less than commercial users. So the water utilities take action to replace um, commercial users, because the consumption will be impact for more impact for the consumption reading. So better we they spend the money to replace on commercial users, not domestic users. So for the conclusion, meter replacement program is important to get the data accurate. That's what I mean. Not only just to increase the billing data, is important to get the accurate data. Okay, the accurate data can use for analyze of another composition like that's figure in meter accuracy, what so on, to projection of demand and to make a planning for the future. And of course, the when we replace the meter, the revenue can increase and will be more income for the water utilities company. And of course, when we get the money, they can provide more facilities and to improve service. I think that's all my presentation. So if any question, just ask me at the QA session. That's all. Thank you.